So, one day, I was sitting in a practice room in the Juilliard School. February 27th, 1973, as I was in my final semester. And I was fascinated. All of a sudden, I discovered a very special phenomenon. Which exists in music, and also one could use this phenomenon for composition and improvisation. And it starts simply by looking at an octave, and now we will divide the octave into two equal parts. We have this interval, which I call a symmetrical axis, and it divides the octave into two separate equal parts, both with 1, 2, 3, 4, 5, 1, 2, 3, 4, 5 other tones in between each step. In total, therefore, 12 tones. Now, what I discovered was just simply taking one of my favorite scales, which Debussy used to like to use quite a bit, and Ravel. That's a little bit of Lydian music, so I decided, okay, let's try to see what happens with an irregular distribution of notes, because you can also be perfectly symmetrical with your usage of the tritone. But I'm going to now take a look at the Lydian mode. This is a major scale with a sharp fourth, which is the tritone. Now what we have is an irregular distribution around the perfect symmetry of the tritone. Looking at this again, we have two notes above C, and here 3 notes above F sharp. This is an unequal distribution around an equality, which is a symmetry, called the tritone. Now what I will do, I will spread all of the 7 notes outside the octave and make a nice chord. And then we will listen to every separate tone, and we will notice that one of the notes that belongs to the tritone will appear to be dominant in this structure. So, E, D, G, A, F sharp, B, and now I will add the C. And we notice a special dominance of this note in relation to the others. And I was so fascinated, I said, wow, one of these notes dominates the entire structure. Could it just simply be that within the octave, it's got less interference above it? So I decided, why not try another example? We'll try one with the flat 7. There we still have 3 above F sharp and 2 above C. And then I built a chord of this nature. Two, three, four. And now I play the C. I said, oh, it doesn't matter whether it's Lydian or Lydian with a flat 7, this note still obtains its dominance. I call it, therefore, a symmetrical root, and we could use this note and transpose to other tritones, just, for example, like Debussy would have done, Scriabin would have done, Bartók, Stravinsky, even Bach. With Bach's secondary dominant, we have interesting movements of tritones. This is therefore the next idea that I said, well, we could just simply move the tritone in some sort of logical pattern, and therefore, with the freedom of using all of these 7 notes in a chord, we can develop a new type of jazz harmony or classical harmony. And for example, I'll just simply play a chord progression of this nature. So I will use now F as my begin because it's all white notes. Now F will be the note instead of C. F is the dominant note, and then I will just simply move F to A flat, that it's the dominant note. Now I will move it to G. And now I will move it to, we have F, A flat, and G. Well, I would think, why don't we analyze this? A minor third down, and then a major second down instead of above the F. So the entire chord progression. Yeah, and there we see, by the recognition of this dominant note, which I call a symmetrical root, we can now expand our harmonics by simply patterning tritones and developing modes, and out of those modes, compiling harmonies. So that was the first lesson, and I hope you enjoyed it. I have a name for this called Symmetry as the Fundament of Sound Creation.